Sri Gurubhyo Namaha children, welcome to online class. In periodic classification, you have learned about the classification of elements of some of the scientists. So, the first scientist is Lavoisier. In 1789, he discovered about 23 elements. Out of 23, he grouped into 4 groups, and then after that de Boer is classified the elements, and he made 3 groups in 3 elements in a group as triads. So this triads also not possible for the elements with more atomic number or more atomic mass. And then next Newland octave, law of octave, he classified the elements based on 8 elements in a group, and this also not applicable for all the elements. After that, in 1868, Lothar Meyer developed a new table. The elements are closely resembled in the modern periodic table. How he made a table based on the physical property. The physical properties such as volume, or the size of an atom, the melting point, boiling point, and against the atomic weight. So he made a graph, or he made a plot between the physical property and the mass of an atom, and he observed there is a periodic pattern. So he observed some periodic pattern in the graph. So in this case, by this, so he arranged this. They arranged the element based on the mass. So during this arrangement, so he got some periodic pattern. So this regular change in the graph. Based on that, the Mendeleevs itself, Mendeleevs itself proposed one table based on the atomic number. So the properties of an element or the periodic functions of their atomic weight. So he got some of the relation with the Lothar Meyer. After Mendeleevs also arranged the element. So the every physical and the chemical property of the elements depends upon the atomic mass. Based on that, he made a table. So in that, during that time, how many elements he made? About only 70 elements are there. Only 70 elements. So he made some vertical columns. About 70 elements. He made the vertical column and arranging the elements in the form of increasing order of atomic weight. And based on the periodic law. The periodic law is what? The physical and the chemical property of the elements are the periodic functions of their atomic number. So by increasing the atomic mass, the periodic property, the property of their physical and the chemical property also can be changed gradually like that. So he proposed a table. He proposed the table and he left some of the blank spaces. Because in future, if we discovered any element, we can able to place the element in that place. So he made a table. He made some vertical column. In that vertical column, he arranged the element in the form of increasing order of atomic mass. And about how many elements? Only 70 elements. And he left some of the blank space in the table. In that, if any elements, new elements we find that similar to that, we can able to fill in that space, and he made a blank space. Now you can see that this is the vertical column prepared by Mendeleevs by increasing order of atomic number. He left some of the places. Now here the gallium is placed here, and then the silicon So he left the places in, he can see this here, some of the places were left, here some of the places were left. So he arranged the element in the form of increasing order of atomic number. Before arranging this table, he didn't discover gallium and he didn't discover about silicon. And next you can see that by arranging increasing order of atomic number, tellurium and iodine, there is a change in this also, in this case. So before inventing or discovery of gallium and silica, he predicted the value. If suppose we have a element, we want to place in this, where we want to place in the place after aluminum, he left the blank space, and then after silica, germanium, after silica, so he left these places. Before inventing discovery of gallium and germanium, he predicted the value, some of the physical values. So what he predicted, so he predicted, what he predicted, the atomic mass. The atomic mass is going to be 68 before discovering the element. Before discovering the element, he predicted the value, and the density is going to be about 5.9 gram per cubic centimeter, and the melting point of the gallium is low, and they can form trioxide with the element, and they can form trichloride from the element. So this element should place after aluminum. For that he gave the name as what? Eka aluminum. In that time there is no gallium at all. He didn't discover about the gallium. Before discovery of the element, he predict, if suppose if any element present, that may be like this only. So he named as what? Eka. So why it is called Eka? After aluminum. This element is going to be placed after aluminum, so that it is called what? Eka aluminum. After discovery, the element or undergo the experimental observation. By this we find out what is the atomic number weight, 70, almost is equal to the predicted value, and the density is almost same, and the melting point is low only. 29 means what? Below the room temperature. So the gallium can be found in the form of liquid in room temperature, because our room temperature may be about what? 30, 32, even in summer 40, 42 also. So it is found in the form of liquid. So low melting point only, and it can form trioxide and trichloride. So before discovering, he predicted some of the elements. See, he worked out about, or he studied about the elements. And next one, again, Eka silica. After silica, if any element found, that may be have the atomic weight as 72, and the density is 5.5, and the boiling point is very high. They can form dioxide and tetrachloride. So that for this case is going to give what? Eka silicon, because it is not discover any element, only prediction. Based on the prediction, he gave the name. After the discovery of germanium, see that the atomic mass is 72, almost near, and the density also almost near, and the boiling point is 947 degree Celsius, and they can form dioxide and tetrachloride. So he predicted, what he predicted, now listen. So he predict the physical and chemical property, and there are missing elements. The missing elements, see, the missing elements were discovered and found the predicted property. So what? So the discovered element is gallium is going to be placed in third group, and germanium is going to be placed in fourth group. Understand? So during this time, during this time there is no gallium and there is no germanium. There is no gallium and there is no germanium, but he kept the blank space. He kept the blank space and predicted value there. So before that gallium, what is present in that third group? See, the third group is aluminium, so Eka aluminium, Eka aluminium, and the fourth group silicon, so it is called what? Eka silicon, germanium. So now this can be, and some of the difference, not only among this, is some of the difference in arranging the increasing order of atomic number. So the anomalies of Mendeleevs periodic table by arranging increasing atomic weight. So there is a difference. There is a difference in that. So what are the difference in that? So some of the elements with the similar property. So here why we are going to make a table by arranging the elements in a group with similar property. If first group element means all the elements are same physical and chemical property. Third group means they all have similar physical and chemical property. In that way only we are going to arrange the element, because to study about the element is very easy. So while in this case the Mendeleev table, the similar properties are placed in different groups. So the similar property elements are placed in different groups, and dissimilar property elements are placed in same group. So there is a correlation here. See that, so similar property cannot be placed in the same group, they are found in different group, and the different property elements are present in the same group. For example, here the tellurium. The tellurium is, the mass of tellurium is 127 and it is placed in 6th group, and iodine is 127.0 and placed in 17th group. So if you arranging the element in increasing order of atomic mass, 127.6 is greater than what? 127. So the iodine should place first, and then the tellurium is going to be placed next. But due to that, because the chlorine, tellurium, the tellurium in that group, they are similar in their property. They are similar in their property. Now you can see that selenium, tellurium, and sulfur, selenium and tellurium are in the same property, so that he placed in that group. And then chlorine, so here sulfur, selenium, tellurium are in the same property, so that he is placed in the same group. And then chlorine, bromine, iodine are have the same property, so that in that same group. But while arranging the increasing, see that atomic mass 127.6, here the iodine is 126.0 or 9, 126.9. So which one is greater? The iodine. Actually tellurium should place here and the iodine should place come this. So they are dissimilar property in the same group. So this is one of the difference, one of limitations of Mendeleevs table by arranging atomic weight. And next, based on the atomic weight, the properties. So there is a property, the periodic, so now cobalt and nickel. The cobalt and nickel also can be placed in this different, you can see that cobalt and nickel, the cobalt and nickel. Cobalt and nickel, almost they are different in that, but they are found in same group, iron, cobalt, nickel. And these are all the, so base there is a difference, in the periodic table. So the Manley periodic table is arranged based on increasing order of atomic weight, also have some limitation. After that we will see that about the modern periodic table. Thank you.